and today I'll be walking you through DEX prototype, our demo. So let's start with our highlights. Currently, DEX prototype is implemented with new core ISIS in Iroha 2, and our currently supported liquidity source is XYK liquidity pool, which is a classic approach, and algorithms are based on Uniswap version 2. So we'll be showing the functionality related to that. And here you can see our new ISIS in Iroha. So basically, these are DEX management ISIS and ISIS related to XYK pool management. So first of all, it's initialization. So we can create a new DEX in domain. It's creating token pairs like XOR.pair. So we can create token pairs, remove token pairs, and add liquidity sources for these token pairs. As I said, the only liquidity source currently supported is XYK pool. So we have ISIS for that. We can add liquidity. So basically depositing token to that pool. And the pool tokens are minted in return for adding liquidity, which can be used, which can be burned with remove liquidity EC to withdraw initial tokens back. And also we have swapping ISIS. These are two because one is taking desired input quantity, and the other one is taking desired output quantity of tokens, which user wants to be swapped in return for the other type of token. Okay, so let's proceed to our use case. We'll showcase like two liquidity providers and one user wanting to exchange token. So here's our initial state. We have 3 user accounts. The user A account has some tokens, some XOR, DOT, and KSM tokens. Also, user B has XOR and DOT tokens, and user C has 2000 KSM tokens. Below, you can see the pool storage accounts, which were created with pool initialization ISIS and are linked to the pools. Here on the scheme, therefore, showing the amounts of tokens transferred between accounts. So our first step is that a liquidity provider wants to deposit all of his tokens into the pools. So he deposits them in both of them and receives pool tokens in exchange. These are some amounts of pool tokens. Next step, these are the formulas for these calculations, and initial provider also needs to sacrifice some minimum liquidity, which is considered, which is constant and considered to be negligible compared to token value, and that minimum liquidity is needed to highly reduce risk of situation of pool being too expensive for small providers to add liquidity. Okay, so now the second account.
Can you explain that last point some more? Just trying to understand.
About minimum liquidity, yes. So yes. As you can see, we need to calculate amount of pool tokens from our reserves, which is calculated by the square root, and our minimum liquidity is basically deduced from the initial adding liquidity in order that there should be some amount of liquidity maintained in the pool, so that the pool would not be so unbalanced that small providers which cannot afford to put too much liquidity, so they could be able to still add liquidity in that. So I cannot go in more details for that. It's it's better described in the Uniswap white paper, so we can refer to that later. So have I answered your question and we proceed? Okay, let's go next. We can return to that later. So our second case is that user B also wants to add some liquidity. He wants to deposit 500 of XOR and 500 of DOT, but because there are already proportions in the XOR DOT pool, which was set by the user A account, he cannot deposit all of his pools, but only 500 XOR and 333 DOT, so that proportions in the pool are preserved. And he also received some pool tokens for that. And calculations for the pool tokens in that case are the following, but let's not spend too much time here. Let's go next. And here's the interesting case, is the actual swap. The user C, which had 2000 of KSM tokens, wants to swap them for DOT tokens. And basically he calls the swap EC, and with that he transfers his 2000 KSM to the first pool, which in this classical approach deduces fee right there, and as an output of the pool transfers the XOR into the second pool, which also swaps it for DOT, and the DOT tokens are returned to the account. So here is the exchange happened. And in more details, here is the calculations for that swap. And as you can see here in XYK formula, that's demonstrated why the pool actually called the XYK pool is basically that it needs to preserve constant product, so that constant product is not changed by adding tokens from each side. So basically here are calculations and adding fee, and those are the numbers which are achieved in the demo, which is for KSM XOR pair, and the same calculations are for XOR dot pair. And finally, we can demonstrate that the user B can retrieve his original tokens which he added by burning his pool tokens, and because there was a transaction made by the user C, he actually gets some profit from that. And here you can see that his constant product has increased while proportions are saved, so he has some profit because of fees. And finally, we can go to the demo, which will be in a CLI interface extended from Iroha 2. So first of all, let's start Iroha itself. And while it's starting, I'll walk you through these scary CLI commands. These are basically initial environment which is needed. Those are free accounts, which was shown on first slide, free accounts, and 2 storage accounts, which are created by pool initialization. So let's walk line by line. We have, firstly, we create a domain. We register an account, which is a DEX owner, and this DEX owner is used to initialize the DEX. By the way, these are all commands performed by root, or they can be set as initial state, first block. Okay, we also need to register assets, which are XOR, DOT, and KSM assets. And we can create token pairs, the XOR DOT token pair and XOR KSM token pair. And we also need to initialize XYK pools for both of these pairs. Now we create our accounts, which is account for user A. We mint initial quantities of all tokens for this account. Also, we need permissions to transfer them. The same goes for user B, which has some 500 XOR and 500 DOT, and some permissions for transfers also. And finally, user C, which also is minted 2000 of KSM, which he'll use in swap. So to save time and not paste all of these CLI commands in real time, we have some small script which will do it for us while we are moving on. So that was our initial state, and now the CLI commands that are referring to our demo. So let's first check our initial state of the account. So these are tabs referring to different configurations on clients. So we have user A configuration, user B, and user C. So we first check user A account, let's just see how much of the assets he actually got initially. We can see he has got 4,000 of DOT, 3,000 of KSM, and 12,000 of XOR. So also got permissions, but let's move next. Also, we can see that we have our storage accounts, which are currently empty because the pool was just initialized. And same goes for the second pool. Now we use the following command, which is DEX YK pool, identification of the pool, and add liquidity with indicated amounts which user A wants to deposit, which is 6,000 XOR and 4,000 of DOT. So let's move to that. We perform these actions from the identity of user A. And let's do the same for the second deposit. And now let's recheck our account of user A. So now we can see that he has 0 DOT tokens because he deposited them, 0 KSM tokens, and 0 XOR tokens. But now in return, he has received new tokens, which are XYK pool XOR DOT. These are pool tokens for the first pool and for the second pool with some quantity. Now let's move next. Our second step is for user B to also add liquidity. So let's proceed to user B. Let's check our initial state of user B. This is basically 500 of XOR and 500 of DOT. So now user B wants to also add liquidity to the XOR DOT pool. And now we can check again. So we can see that user B has received also some pool tokens for his deposit, and he has 0 XOR tokens, but not of all of his DOT tokens were deduced because of the pool proportions. So he has some DOT tokens left. Now we can also check our pool state, which should have some XOR from 2 providers and also some DOT. And our final user is user C, which wants to swap his tokens, which he has. He has 2,000 of KSM tokens, and he wants to swap them for DOT tokens. So basically, there is no direct pool from KSM to DOT right now. So the user indicates a path, which is KSM XOR DOT path. And these are 2 ECs, one taking desired input quantity and desired output quantity. So let's use our first. And now let's recheck our user C. So instead of his 2000 KSM tokens, which is now 0, he has got a calculated quantity of DOT token. So the swap has completed successfully. And finally, our user B wants to remove liquidity and receive his tokens back. So let's go to our user B and remove liquidity. Now let's check him. So here we can see that he has burned all of his liquidity pool tokens, which is quantity 0, and received back his original tokens in proportions equal to the pool, but now he has received some profit. So here is the end of our demo, and now we can proceed to questions.